In this presentation, we will discuss the formal definition of data structure and we will also discuss some of the advantages of it. So let's get started. What is a data structure? From the previous lecture, we get this information that a stack ADT can be implemented using arrays or linked lists, right? We can use these two data structures to implement a stack ADT. These are my data structures, right? Now, what information we get from this line? First of all, a data structure is the organization of the data in a way so that it can be used efficiently. When I say efficiently, it means in terms of time as well as space. From the previous lecture, we got this information that a stack ADT is implemented using arrays or linked lists. From that particular text, we get this information that a data structure is used to implement an ADT. Isn't that so? We can say that a data structure is used to implement an ADT. We know from this example that in order to implement stack ADT, we can use an array data structure or linked list data structure. Any of these data structures we can use to implement this ADT. So basically we can say that a data structure is used to implement an ADT. ADT tells us what is to be done and data structures tells us how to do it. So data structures cares about how, not what. ADT just gives us the blueprint while data structures gives us the implementation. But how to know which data structure to use for a particular ADT? That is the basic question. Obviously, this question immediately arises after knowing this point that there are multiple data structures for a particular ADT. But which data structure to use for a particular ADT is the question of concern. Let's tackle this question. Which data structure? In reality, different implementations of ADT are compared for time and space efficiency. For example, we know that stack ADT can be implemented using arrays or linked lists. We can compare these two data structures for time and space efficiency. The one best suited according to the current requirement of the user will be selected. Maybe one data structure will lead to space efficiency while other data structure will lead to time efficiency. We will select the one according to the current requirement of the user. Maybe user wants to save space, then we can use a particular data structure which can save space. Maybe a user wants to run the program faster, then we will use the data structure which will run faster. So the one best suited according to the current requirement of the user will get selected. Okay, so it is depending upon the user. Now let's discuss some of the advantages of data structures. First advantage is efficiency. We know that proper choice of data structures make program efficient in terms of space and time. Proper choice of data structure is very important. This leads to space and time efficiency. Second advantage is reusability. One implementation can be used by multiple client programs. Just one data structure can be used by multiple client programs. So reusability is also provided by data structures, right? Apart from this, the one advantage which we already know is abstraction. Data structure is specified by an ADT. ADT is the blueprint while data structure is the implementation. So we can say that it provides a level of abstraction, right? The client program doesn't have to worry about what is going inside. It just sees the ADT, just the interface, nothing else. So these are the advantages of data structures which we should remember. Okay? Okay friends, this is it for now. Thank you for watching this presentation.